Now let's move to another rendering-related resource, video playback systems. Specifically, we will discuss memory usage associated with video players. In production projects, the two most commonly used video playback solutions are Unity's built-in video player, third-party solutions such as AVPro. After discussing shaders and render textures, a natural question arises. Could video playback plugins also introduce hidden memory overhead? And more importantly, can we detect this overhead by comparing engine-level memory profiler data with system-level memory monitoring tools? Let's look at the experiment results. First, from the iOS perspective. When using Video Player, we analyzed graphics memory behavior using metal capture tools. Metal capture is extremely useful. It allows developers to inspect frame rendering sequences, individual draw calls, resource usage per pipeline stage, execution timing of rendering operations. While metal capture is often used for performance timing analysis, it also provides valuable insights into memory residency. Inside graphics memory statistics, we observed additional texture allocations. When video playback was completely stopped, base texture memory was approximately 46 megabytes. When video playback was enabled using camera far plane rendering mode, additional textures appeared. Let's break this down. We observed one texture around 7.25 megabytes and 16 smaller textures around 3.52 mega each. Total additional memory, approximately 56 megabytes, distributed across 17 textures. The 7.25 megabyte texture is correlated with rendering resolution. The 16 smaller textures are associated with video playback resolution buffering. In this experiment, video resolution was fixed at 720p. Texture format was 32-bit. Theoretical memory calculation matches observed allocation behavior. The key takeaway is this: even simple video playback can introduce significant memory overhead. Next, we tested parameter adjustments. First, we reduced video source resolution. When lowering source resolution, memory consumption dropped to approximately 1.64 megabytes. This result is expected. We also tested playback region dimensions inside the inspector settings. For example, changing the playback area to 1024 x 12024 increased memory usage to about 4 megabytes. This behavior is consistent with rendering buffer scaling. Bitrate mode was also tested. However, bitrate mode adjustments showed only marginal impact. Memory decreased from 1.64 megabytes to about 1.59 megabytes. The difference was not significant. Another parameter is spatial quality. When set to low, memory consumption was reduced to roughly 1/4. Using the graphics memory viewer, we inspected texture properties. Interestingly, some textures did not change dramatically in structure. The main change was resolution scaling rather than format transformation. Video playback can also operate in RT-based rendering mode. In RT mode, in addition to the 16 small textures, 2 render textures appear at the top layer. These are labeled video target buffers. Their memory footprint was approximately 10 megabytes, 8 megabytes. The size of these buffers is determined by target texture configuration. Now let's briefly look at Android behavior. Using memory profiler analysis, we observed similar patterns. Both Video Player and AVPro systems were tested under 720p playback, 1080p playback. Additional memory allocations were observed in render texture buffers, untracked memory regions, runtime executable memory segments. This confirms a key insight. Video playback plugins are not only texture consumers, they also interact with GPU buffer pipelines, driver-level memory management, runtime allocation layers. Finally, here is the engineering conclusion. When optimizing video playback memory, you should not only focus on playback codec or bitrate, you must also consider rendering buffer residency, resolution scaling strategy, plugin implementation behavior, system-level graphics allocation. Because in modern mobile engines, memory cost is often distributed across layers, not concentrated in a single resource. That concludes the video playback section.